Hey guys, welcome to section 0.3 where we're going to be graphing linear equations and inequalities. I'm going to split this lesson into two videos. This is the first of the two, and we're just starting with graphing linear equations by hand, which is your first learning target, as you can see right at the top of the page. Here we go. I can graph linear equations by hand. Okay, let us get started. When graphing lines by hand, we prefer to have the equation in slope-intercept form. Once the equation is in this form, we can do the following. Identify and plot the y-intercept. From the y-intercept, use the slope to plot at least two additional points. And connect the points using a straight edge and draw the line through the entire graph with arrows at each end. So let's first review. Yesterday we spent time, or the last lesson we spent time writing equations of lines. And remember, slope-intercept form is y equals mx plus b. Once we have our equation in this form, it's very simple to identify the y-intercept and the slope, hence why we really like this form for graphing. Let's take a look at example 1 with the instructions that we do need to cancel out a couple of these. We just need to have them say graph each linear equation. Letter A is 4x minus 2y equals 6. This obviously is not in slope-intercept form. In fact, this is in standard form. Standard form is when we have the variables on one side and the constant on the other. So we have to do some moving around. We need to get y by itself. So the first thing I'm going to do is get rid of 4x by subtracting 4x from each side. That leaves me with negative 2y equals negative 4x plus 6. I always like to write my x term before my constant term so that it's already kind of ready for slope-intercept form. I have one more step. To get y by itself, I need to divide by negative 2. I divide every single piece by negative 2. And when I do that, I end up with y equals a positive 2x minus 3. And now my equation is in slope-intercept form. The y-intercept, right there, is 3. Our slope is 2, but remember, we think rise over run, that would be 2 over 1. So when we go to plot or graph our line, we plot our y-intercept down at negative 3. From that point, we count our slope up 2 over 1. I always go up and right. This will be positive because what is happening as we look at our dots from left to right, they are getting higher, they're increasing. And that makes sense, it's a positive 2 slope. Then we connect our dots as straight as possible. Straight edges are highly recommended. And put arrows at the end. And that is our line, y equals 2x minus 3. Letter B actually is a little more simple because we just have 3y equals negative 2x plus 6. So the only thing we need to get rid of is this 3 on the y. So we divide everything by 3. We are left with y equals, now negative 2 is not divisible by 3. We just leave that as a fraction, negative 2/3 x plus 2. So our y-intercept, our b value, is positive 2. Our slope is negative 2/3. So our slope is negative this time. That means our line is going to be going down from left to right. So when I plot my y-intercept at positive 2, I go ahead and count my slope from there. Because it's negative, instead of going up, I'm going to go down 2 and right 3. Unfortunately, I can't continue counting that way because my graph stops at 5. So I'm just going to reverse that. I was going down to right 3. I could also go up to left 3. And I get another point in the same line. Finally, just connect your points. And there we have it. So those are just kind of normal lines. They have a slanted slope. Sometimes we have lines that slopes are special, like horizontal and vertical lines. Horizontal lines obviously goes from left to right. Think of the horizon. It's also known as a constant line. Vertical lines go up and down. Now, horizontal lines, because they're straight across like this, they always stay at the same y value. So the change in y is 0. Thus, when we use the slope formula, remember that slope formula, which is, here, I'll just write up here for y2 minus y1 over x2 minus x1. That means that our y values are going to be the same, so the numerator of that slope formula would be 0. So we're only taking 0 divided by something, but that always results in a slope of 0. Which should make sense because slope is rise over run. Well, this horizontal line has no rise. Okay, so the rise is 0, the slope is 0. So what happens is your equation ends up just being y equals b, because you would have a 0. Before that, you would have y equals 0 times x plus b. If you put 0 in for the slope, well, 0 times x is just 0. So it's just y equals b. A vertical line goes straight up and down. So what we know about this is the x values never change, so the change in x is 0. And that would make the denominator of our slope formula 0. Unfortunately, we cannot divide by 0, so the slope of a vertical line is undefined. Okay. And we can't even write it in slope-intercept form. We write it actually as x equals some constant c, which is whatever that x value is that that line is going through, because it stays the same the whole time. Okay, so let's graph a couple vertical and horizontal lines. Graph the horizontal and vertical lines on the same set of axes. Label each line with its equation. So I'm going to start with letter A. Y equals -3. So this is technically in slope-intercept form with a slope of 0. This is our horizontal line. Everything is staying at -3. So that would be right down here. Y equals -3. If you look at B, we have x equals. That's a big hint. That's a vertical line at the x value of 4. So we go to the x value of 4. We draw that, and there we have x equals 4. If we look at C, we have y equals 2. That is another slope-intercept form with a slope of 0. That's a horizontal line at the y value of 2, +2. And lastly, we have the equation x equals 0. That is actually right on the y-axis, because on the y-axis, every x value is 0. And there we have graphing linear equations.